Hello, grade 10s. So nice to see you all again. And Tlafatso, Akila, Tsetso. Who else is with us? Jared, welcome back. Anam, nice to have you with us again. And Sam. So you can get started on the do now. You're going to need your calculators. So Kelebuchile, nice to have you back with us again. And Katlejo. You guys can get started on the do now. It's what we were doing last time, where we were using two sides to calculate an unknown angle. And Nawazi's back with us. Cool beans. Who have I not said hello to? Katlejo, I don't know if I've said hello to you. Welcome back. And Tisetso, welcome back again. And David's with us. Cool. Welcome back, David. Get started on the do now. It shouldn't take you guys too long, I hope. Anson and Klantla, welcome back to you too. That's a little bit better. Sorry, it was a bit small before, wasn't it? Sorry, grade 10s. I think that's a bit better now. Oh, you're not going to do reciprocal ratios this year, Katlejo. Thanks for telling me that. Has anybody else's teacher said the same thing to them in grade 10, that you're not doing reciprocal ratios? If you can just pop that in the chat, it would be interesting to hear. Okay, so your teacher said the same thing, Sam. Well, okay, thanks. Katlejo, it's not the end of the world. Thank goodness in the CAPS syllabus, we talk about the reciprocal ratios in grade 10. But we don't actually use them in grade 11 and grade 12 at all. So to be honest with you, you're not going to be disadvantaged in any way. And I can understand if your teachers were running out of time and trying to fit things in before the end of the year because of all the time that's been lost because of COVID, I could understand why they would choose, to leave that out. I mean, I'm a grade 11 and a grade 12 teacher. And so, knowing what I know about what you're going to be doing in the next couple of years, it's not going to disadvantage you at all. So don't worry about that. I mean, obviously, then they can't put it in your exam either. Hello, C. Claire. Welcome back. Nice to have you with us. Hope everybody's got their calculators with them this evening. Although some of the stuff that we're going to be doing tonight, we actually don't need a calculator for. Okay, Marumo says the answer is 28,07. I must be honest, Marumo, I don't remember getting that as my answer, but maybe my brain is just a bit foggy. Does anybody else have an answer? Oh, shame, Katlejo. Yes, it's okay, David. Maybe I'm going crazy because you've got the same answer as Marumo. Yeah, oh, shame, Katlejo. Yeah, I know it's SA Sam's, isn't it? And it does actually create a lot of problems. We've had the same thing at our school as well. So you're not alone. Hello, Phoebe. Welcome back. Are you feeling tired? All those. You just like that emoji. Yeah, it is cool. You're very funny. Okay, well, as long as you don't think I'm completely boring. Big D, hello. Hello, Big D. It's not a name I remember seeing here before, but anyway, welcome back. Okay, Anam, you got 61.93. All right, so now how much time have we wasted here? Well, not wasted, but me talking away here. Yeah, I got the same answer as you, Anam. Hi, Nizole, welcome back. Okay, so a couple of you have had a chance to put your answers up, and I'm going to go back. Marumo, you said 28.07. Can I please ask, what trig ratio did you use? Did you use sine theta, cos theta, or tan theta?
Ma'am, I used tan theta.
You used tan theta. Well, that's the same one that I used too. Okay, so I said tan theta. I agree with you. I said tan theta too. And I said tan theta is opposite, which was 6, over adjacent, which was 3.2. Did you say the same thing?
Oh, no, ma'am, I swapped them. I say 3/2. 3,2/6.
Over 6, there we go. Okay, all right, so that's fine. Never mind, it's a little mistake. Okay, so remember the tan of the angle is opposite over adjacent. Okay, it's not going to be the same thing the other way around. Okay, so David, you must have made the same mistake as well, where you put the 3.2 at the top and the 6 at the bottom. Okay, and that's where I got my answer from. And everybody remembers how to calculate an angle. You've got to tell the calculator shift and then put in the 6 over 3.2, okay, for it to calculate the angle. Are there any questions, or can we move on? Okay, well, unfortunately, we're not doing trig graphs today, Katlejo. We're doing the Cartesian plane, unfortunately. But hopefully some of the things that you'll learn today will be useful to you tomorrow. Trig graphs is an entirely different, well, it's not an entirely different section, but you know, we could spend another 6 lessons just talking about trig functions. Okay, so what I wanted us to move on to today would be sort of the next thing that your teachers would teach you after you've done SOH CAH TOA and you've learned how to calculate a side from an angle and a side, and then how you've learned how to calculate an angle from 2 sides, which is what our last 2 lessons covered. So now the idea is we're going to take our right angle triangle and we're going to pop it onto the Cartesian plane. Okay, so you know what the Cartesian plane is, our set of X and Y axes. And what would happen is it would look like this. All right, so I don't want you to be overwhelmed by this diagram, but just have a look here. On the left-hand side, so over here, we've got triangle PQR, right? That's this triangle over here, PQR. All right, it's a right angle triangle. And if this angle over here is theta, side PR is the opposite side, the adjacent side is QR, and the hypotenuse is always going to be opposite the right angle. Now imagine we take that, like the arrow shows us, and we put it onto the Cartesian plane. Okay, so you can see now where, let's just rub all of that out. Okay, the purple line on the Cartesian plane is the same as what line on our right angle triangle? Who can tell me that? So the purple line over here, this purple line here,
It's the radius.
It is the radius, you're quite right, it is the radius, but in terms of the right angle triangle, indeed. So Nozole, Harry, perfect. It's the same as line QP over here. All right, so all we've done is we've taken this and we've put it onto the Cartesian plane. Can you see as well, grade 10s, that our angle theta over here would now lie between the x-axis and our radius. So this would be theta in here. Okay, so there's QP, quite right. So now Q is now where O is at the origin. Here's P up here, there's R down there, and there's our right angle. So when we take right angle triangles and we put them onto the Cartesian plane, we now have different names for what we had before. So instead of us calling QP the hypotenuse, we're now referring to it as the radius. And I'm going to explain to you why it's called a radius just now. Similarly, all right, we've got different names for the others as well. So our y, or the length of what was PR, so that would have been this over here, the y coordinate at point P is the same as opposite, okay? It's the length of this line. And the last thing is the x. Let's choose a different color. So the distance from the origin to the x coordinate, okay, is now this line over here. And we call, instead of us calling it adjacent, this is now the x coordinate. Okay, so you have to learn that before we had SOH CAH TOA, and now we've got slightly different names because we're working on the Cartesian plane. So when we work with sine, we are working with y and r. So O is now represented by y, and the hypotenuse is now represented by r. As far as the CAH part from SOH CAH TOA, so we're working with the cos of the angle, and it's represented by x over r. No problem, Tatuka, glad you could make us. And the tan could make it here to be with us. And the tan of the angle is now going to be opposite, which was now represented by y, and adjacent, which is now represented by x. And we'll talk a little bit more about how you can remember that. For now, what I'd like to do is this little activity that I've got here on the side, which relates to the diagram that we can see. So if you don't have to do the reciprocal ratios, then we can certainly leave these out. I wonder if I should just make this a little bit smaller. And maybe I should move. Is that okay? Can everybody see that all right? Is it big enough? Not big enough. Is that a bit better? Okay, all right. So sorry, it's just a little bit difficult to fit that in on here as well. I think what I'm going to do, maybe make that a little bit smaller and then drag this over here. Okay, and let's see how this goes. Okay, so we're going to do this together. All right, and then there are a couple of things that you guys are going to do on your own, but don't worry about that. I want to support you through this first. All right, so you can write this down in your books because it's important that you know this. All right, so we've got SOH CAH TOA. Okay, so SOH, this is the SOH part, and it is equivalent to y over r. Okay, so this is on the Cartesian plane. Then when we've got the cos of the angle, we've got A at the top over here, and that's the equivalent as, can anybody remember what needs to be over here? So what goes at the top and what goes at the bottom if we're talking about on the Cartesian plane?
Ma'am, is it A over H?
It is A over H, but I want you to use the equivalent on the Cartesian plane. So instead of A over H, what are we going to write instead of A? We're going to write
R.
We're going to write
X over R.
X over R. Good. Well done. Okay, so it means exactly the same thing. But when we're working on the Cartesian plane, we don't have an adjacent side and an opposite side anymore. Okay, we've got coordinates at the end of the terminal arm, And the x coordinate is the distance from the origin to the end over here. And the y is the height. Okay, because remember, y measures up and down and x measures across. So in our old system, SOH CAH TOA, so TOA, the tan of an angle was the opposite over the adjacent. But now it's equivalent to what over what? It's going to be y over x, opposite over adjacent. Okay, so this is important, what we've written here. That I'm drawing the pink block around. Make sure that you get that down. Is there anybody else who is not going to be doing... Sorry, I missed the chat a little bit. X over R, good. X over R, yes, Phoebe, Y over R, Y over X. Yes, okay, so and that was perfect. Sorry, my chat disappeared for a little bit. We can talk about the reciprocal ratios, but I don't want to waste your time if it's something that's been removed. Everybody else, has everyone else also, Katlejo says her teacher has removed, so you're not going to be doing that. Is there anybody else whose teacher, I know Sam also said her teacher, we just learned reciprocals yesterday. Okay, all right. You're not sure. Okay, well, I tell you what, let's just do it anyway. Okay. No, it isn't needed. You don't need them for grade 11 and you don't need them for grade 12. Okay, let me just whip through this very, very quickly, all right? And then we can continue on. Okay, so if you recall from our previous lessons, we have said that cot was the reciprocal of tan theta. So that would be A over O. So in terms of the Cartesian plane, it would be X over Y. Sec theta is the reciprocal of cos theta. So that would be H over A. And again, that would be equivalent on the Cartesian plane to R over X. And the last one, cosec theta, was opposite. Sorry, I'm talking nonsense. It's hypotenuse. Let me just get rid of that. Hypotenuse over opposite. So here it would end up being R over Y, in case you did need it. All right, let's go on and have a look at the mnemonic that we can use to remember this. Okay, so there we go, our Cartesian plane definitions for the trig ratios of theta, right? So here, grade 10s is R, the radius. And the reason why it's called a radius is because it moves, okay? It's attached here at the origin and it goes in an anti-clockwise direction. This over here is where 0 degrees is. Up here, this is where 90 degrees is. Over here, this is 180 degrees. Here's 270 degrees. And once we've done a full circle, we would come back to the back. So can you see that if this line continued to move, what would happen is that it would trace out a circle. All right, and that's why it's referred to as a radius, because it goes from the center to one point on the outside. Okay, and angles always, when they get bigger, they're always going to be in an anti-clockwise direction. Okay, so when it gets up to 90, it's a right angle. 180 degrees obviously is a straight line, and then 360 would be a full circle. Okay, so that's where it comes from. The other thing that's important to note that I haven't sort of mentioned yet is at the end of the terminal arm, wherever it ends, That is a point on the Cartesian plane. And because it is a point on the Cartesian plane, it can be defined in terms of X and Y. So that's where the X and Y that we were talking about earlier, that's where it comes from. All right. So when I'm talking about sine theta, I am talking about the value of the X coordinate over R, the length of the terminal arm or the radius. When I'm talking about cos theta, then I'm talking about the X coordinate over R, the length of the hypotenuse or the radius. And when I am talking about tan theta, I'm talking about the X coordinate over the Y coordinate. Okay, so it means exactly the same thing as Y means the same as opposite, X means the same as adjacent, and hypotenuse means the same as R. Just like we learned SOH CAH TOA, so there is another mnemonic that can help us to remember our ratios. So SYR, can you see? SYR. So shade your rear, all right? Then CXR, because X-rays. Tan your exterior, so TYX. Okay, so you can learn that, shade your rear because X-rays tan your exterior, and that is SOH CAH TOA in terms of the Cartesian plane. All right, and we've got to start thinking this way because all our trigonometry from this point onwards is based on this principle, including next year. Are there any questions that you'd like to ask me at this point? Is there anything that I've said that doesn't make sense or you want a bit of clarity on? David, you happy? All right. Okay, so the question is, I'm telling you all of this stuff. Yeah, no, it's not as fun. That's right. But that's the best I could come up with. I'm sorry, Phoebe. All right, let's have a look at this example. Where are we going to use this? Okay. So what we've got is a diagram, all right, and point P on the Cartesian plane, such that XOP is theta, so it's been labeled there for you, and they've told us that OP, the length of the terminal arm, the length of the radius, the length of the hypotenuse, is 5 units. They want us to write down all 6 trig ratios of theta, and in some cases, we can give our answer to 2 decimal places. Most of the time, what we're going to do is we're just going to leave it as a fraction. Don't worry, Katlego, when everybody else goes to do the other thing, I will help you specifically with something. Okay, don't stress. All right, this is difficult in the beginning. Okay, so in this case here, they've given us all the information that we need. They've told us what the length of R, which is the radius, OP is 5. They've told us the X coordinate at P is 3, and they've told us that the Y coordinate is 4. So look how we've written sine theta. Sine theta has been written as opposite over hypotenuse, or Y over R, and then we've substituted in what Y is and what R is. Okay, so sine theta is 4 over 5 or 0,8. Cos theta is X over R. So we've subbed in our X coordinate and we've subbed in our R, the length of the hypotenuse or the terminal arm. So that would be 3 over 5. These are trig ratios. So 4 over 5 is a ratio. It's a fraction, but fractions are ratios. Cos theta is 3 over 5, and tan theta is Y over X, so it's the Y coordinate over the X coordinate, so that would be 4 over 3 in this case. I'm going to give you one, okay, and you're going to do exactly the same thing. We're not going to worry about the reciprocal ratios too much since we may not be doing them, but let's have a look at this. I have given you the length of OP, which is R. I've given you, hang on a second, that's not correct. Sorry, there's a mistake over here. The X in this case is equal to -12, and the Y in this case is equal to -5. All right, let's do the first one together. And let's see if you can do cos theta and tan theta on your own, right? So let me ask Sin and Tlantla, all right? I want to write sine theta in terms of this diagram. So I want to write the y coordinate over r, the length of the terminal arm. What should I write in the place of y? Sin and Tlantla. Hang on a second. Yes, that's correct. Okay, so that's the x, that's the y, quite right. I should write that as minus 5 over 13. Good. Do you feel confident to try cos theta and tan theta on your own? This again, okay, that's not correct. So I've scratched that out, but can you try cos theta and tan theta on your own and see how it goes? Is everybody feeling confident to do that? Okay, so Harry says he's lost. Phoebe, you're all right. How's everybody else feeling? Okay, Marumo says you're all right. Okay, so Harry and Katlego, I know you've said to me that you feel very lost, all right? So the others, you carry on. And then, okay, also, I don't understand, David, you say you're all right. I know this is a big step up now. Okay, so things have got quite a lot more difficult than what they were before. All we are doing is writing the trig ratios in terms of numbers. So instead of us working with just letters, now those letters have values. All right, so our mnemonic, our new one, is shade your rear, cos x rays tan your exterior. Okay. Just like O and A and H had meanings, so Y and R and X have meanings. So Y is the same as opposite. X is the same as adjacent. R is the same as hypotenuse. Okay? So when we look at this diagram over here, they've told us what R is. They've told us R is 5. They've told us X is equal to negative 12. And they've told us Y is equal to negative 5. So all we are doing is substituting. Okay, so cos theta is X over R. Cos theta is X over R. So over here, you're going to fill in an R. What is X equal to? Negative 12. What's R equal to? 5. Okay, that's all you have to do. All right, this one has almost been done for you. So tan theta is Y over X. Okay, Harry, all you're doing is subbing in now. Sub in what the Y coordinate is, sub in what the X coordinate is, and this becomes 5 over 12. That's all I wanted you to do. Okay, I hope it seems a little bit easier now. I didn't mean for it to be a difficult activity. You're just subbing in. Okay, so now tan theta has a value. All right, anyway, I've got another one for you guys to try. Let's just see how this goes, okay? I'm not too worried about cosec second cot. Again, have a look here, okay? In the corner down here, they've told you what R is. Remember, when you're on the Cartesian plane, your X coordinate comes first and your Y coordinate always comes second. Always, always, always. So now I've given you what the X is, what the Y is, what the R is. I want you to use shade your rear, because X rays tan your exterior. And I want you to write values for sine theta, cos theta, and tan theta in terms of the diagram. Just give it a try. Even if you get it wrong, it's not the end of the world. We can fix it. Harry, I hope that makes a little bit more sense. And I hope so, Katlejo, as well. Anyone got any questions? That's okay, Katlejo. It's difficult to do two things at the same time. Oh, wow, Harry, you're done already. That's awesome. Okay, how do the rest of you feel? You're all very quiet tonight. Phoebe, Sam, Sihle, Gisetso, Nosisa, Nowazi, Nizole, Kilebochile, Jared, Karabo, Akila, Anam. How's it going? Nizole said you're done. All right, cool beans. Fairly easy. Cool, I'm glad, Sam. No, Maya, it's always like that. Y is always opposite, X is always adjacent, and hypotenuse is always R. Okay, this always like that. These are rules. Okay, because the Y coordinate corresponds with the opposite side from theta. The X coordinate corresponds with the adjacent side to theta. So always. Okay, David, you say that you're done. Okay, so pleasure. I hope that makes sense. All right, guys. So for sine theta, that's fine, Sihle. All right, no, I've already picked on you, Sinan. That's not fair. Okay, David, what did you write for sine theta?
-8/10.
There we go. Perfect. Well done. -8/10. Perfect. All right. 100%. Well done, David. That's hundreds. All right. I'm really pleased. Now, Harry, you said that you were finished so quickly. Can you tell me what you got for cos theta? Yes.
Ma'am, how did we get -8/10?
No problem. All right. There we go, Harry. Ach, no, sorry.
No, ma'am, you don't understand.
Sorry. I'm wrong here. It's not -8/10. It's 6. Quite right. Sorry. Yes, Phoebe. My brain is not working. This should be 6/10. Okay, because now maybe that's why you were asking. It needs to be the Y coordinate over the are the length of the terminal arm. So 6/10 is correct. And yes, you should simplify. Okay, so both of those numbers can be divided by 2. So we would end up with 3/5. Okay, my apologies. That must have been confusing. All right. Okay, so Harry, cos theta is supposed to be?
-8/10.
There we go. All right, 100%. Okay, so this is now -8/10. Let's get a better color. -8/10. And then again, we should try and simplify our fractions. So both of these can be divided by 2. So that would leave us with -4/5. Good stuff. And oopsie, who are we going to ask for the last one? Sinenhlanhla, what did you get for tan theta? You got 6/-8. Harry, I'm going to answer your, oh no, it's Nizola that's asking. And no, Nizola, you're asking the same question of me. I'm going to answer your question right now. Okay, so here we should have said our answer is 6 opposite or y over adjacent, which is -8. And again, if we simplify our answer, divide both of them by 2, then we would end up with 3/4, but it must be negative. Now, Nizole and Harry, you've asked a very good question. Do you lose marks if you don't simplify it? And I think this is at the discretion of your teacher. I know at the school that I teach at, if this was a test and you didn't simplify, we would still give you the marks. Right? Because we're not testing, do you know how to simplify fractions? We're testing, do you understand shade your rear because x-rays tan your exterior? So for me, you know, -8/10 is -4/5. So I would not penalize you for that, but you need to make sure with your own teacher. Okay, if you do go ahead and simplify, then there's no ways that they can penalize you because you've done the right thing. But just double check with your own teacher. But yeah, as I say, I mean, 6/10 is 3/5. So, you know, at my school, we wouldn't penalize on that. But yeah, just rather check with your own teacher just to be 100% certain what the expectation at your school is. Certainly at matric level, you in your final exams, you would not be penalized for something like that. Okay, but because you're in grade 10, let's just make sure. All right, so now here is one for you to try on your own. All right, so again, we're not going to worry too much about the reciprocal ratios. Let's just worry about sine theta, cos theta, tan theta. So sine theta is, cos theta is, tan theta is. Someone sent me a message. Oh, you've already done that. Okay, Harry, that's brilliant. I'm going to show you the next thing right now. Okay. So everybody, let's get this done quick. And then we can move on. And you can pop a smiley face or a done or whatever it is in the chat when you've finished. Cool, Lorraine. Well done. Good, Sinenhlanhla. Maruma also done. Good job, guys. Nozola happy. Yeah, cool. Okay, so Lorraine, I'm going to call on you. What did you write for sine theta? Cool, Phoebe. What did you write for sine theta, Lorraine? Nice, Sam. Lorraine, did you hear me? Okay, never mind. Sam, take it away. Sine theta, what did you write? Agreed, Nizole. That is 8/17. Sorry, Sam, go for it.
Ma'am, it's negative 15/17.
Excellent, Sam. Well done. Very nice. Okay, and then the very last one, tan theta, what did you get, Phoebe? Good, excellent. Minus 15/8. Okay, and there was no simplification necessary because there weren't any common factors. Okay, good job. Well done. Now we're going to take things one step further. All right, so my question to you now is, if we have a look at this diagram over here, something is missing. All right, now when I say something, in these types of questions where you're working on the Cartesian plane, X, Y, and R are the three things that we always have to have, okay? We can't answer any questions unless we have all of them, okay? Because then we have to be able to write sine theta with Y and R. We have to be able to write cos theta with X and R. We have to be able to write tan theta with Y and X. So these three things, X, Y, and R, are best friends, and all three have to be together in order for us to answer any questions, right? They've given us the coordinates at point P, and they've told us we need to calculate the value of sine theta. So when they say they want sine theta, what do they want? What over what? And try to stay away from opposite and adjacent and hypotenuse. Try to use the new letters. They want y over r. Indeed, they do. Okay, well done, Phoebe. That's perfect. What's missing from the picture? Can anybody tell me? What isn't there? Aha, there's no radius. Indeed, Nizole. Well done, Snare. Okay, there's no r. Yes. So, how are we going to calculate r? Any ideas? Hey, Harry, too sharp. Well done. Okay, using Pythagoras, exactly, because if we have a look, all right, there is our hypotenuse. If we drop a line down to the x-axis, there is our right angle triangle. Okay, so we can use the theorem of Pythagoras. What is the theorem of Pythagoras? Harry, how does the Pythagoras theorem go? What plus is equal to what?
X squared plus y squared equals to r squared.
Perfect. Well done. Now we need to calculate r because we cannot write sine theta up at the top here unless we have r. So now we're going to substitute. And this is where substituting with brackets and putting your exponents on the outside is so important, grade 10s, right? When we substitute in x, we're putting the negative 12 in brackets and we are squaring it. Then when we are calculating, when we're subbing in y, we're going to put in 5 and we're going to square it and we're going to get r squared. Can anybody, you've got your calculators with me, I want you to put that in and I want you to tell me, please, what r squared is equal to in this case?
Ma'am, isn't it error? Something, I don't know. What?
Now it will be if you don't put it in. Yes, Phoebe, that's quite right. There will be an error if you don't put it in like this. You've got to use the brackets. Okay.
Okay, ma'am. I did use the brackets, but then I'm taking like a long step, ma'am. Whereas, okay, I wrote the second step that you wrote, ma'am. And then I calculate the next step. I calculated what's negative 12 squared. And then gave me negative 144. And I did the very same thing for 5 squared. And then, ma'am, I minused negative 144 plus 95. Plus 25. And then it gave me negative 119. And then I squared it. And then it gave me an error.
Okay, all right. Now it will do that, unfortunately. All right. When you want to, so there's a couple of people who have got the right answers here, but just hang on a second, guys. I just want to help Sam fix this. R is equal to 14. I didn't get 14, Marumo. You should be getting 13 as your answer, but don't stress. I'm going to explain to you now where it comes from. Okay, so when you put this into your calculator, all right, if you just do this, minus 13 squared. Yes, Nazola, you have to square root at the end to get R. Your calculator will give you this. This is, yes, David, quite right. It's not the same as that. Here, the answer is positive 169. Okay, so that's why the brackets are so important. Okay, if you take anything away from this entire lesson tonight, except for shade your rear because X-ray is tan your exterior, the most important thing that I want you to take away from this lesson is you have to use brackets when you substitute and put exponents on the outside. Okay, because these two are not the same thing, all right? Just very, very quickly over here, because I want to give you a chance to try one on your own, all right? If we do this, negative 13 squared, you are telling your calculator to do this. 13 times 13 times minus 1. That's why you get a negative 169. But if you do this, negative 13 squared, like that, on your calculator does this. It says negative 13 times negative 13 equals positive 169. Can you see why it's not the same thing? All right. So yes, Phoebe, the square root of 169 is 13 and R is equal to 13. Quite right. Okay, Sam, I hope that makes a bit more sense. So this bit over here, Harry, you said was 144, which is correct. Plus 25 gives us 169. And then we take the square root. Okay, and R will be equal to 13. So we're taking the square root here, and we're taking the square root over there, and we're getting R equal to 13. So can you see, grade 10s, there's an extra step involved here, because now we have to calculate one of the missing three using the theorem of Pythagoras. Now we have all three. Okay, we've got our X, we've got our Y, we've got our R, right? So let's just go and put what R is over here. We've calculated that R is equal to 13 in this case. All right, so now they've asked us to write the value of sine theta. Okay, so that was given, there we go. So R is equal to 13. Last step now, which I'm just hiding, okay? How are we going to write sine theta from the information that we've been given? Remember, sine theta is indeed. Good, excellent, well done. So what is the value of y in this case?
5.
Aha.
Over 13.
Over 13. Good job. Okay, well done, Phoebe. I see you got that as well. Harry and Murumo, Anam, Jared, Karabo, Kelebochile, Shem, you've all been so quiet this evening, Nizole. How's it going? Did you get that? And if so, thumbs up, thumbs down, everybody. Okay, thanks, Harry. Thanks, Nizole. Mocha Malipe, well done. Good job. Well done, Jared. And Murumo. Okay. Lovely. Well done. Okay. So again, grade 10s, sometimes we just need a little bit of time to understand things. And if you didn't understand it, Karabo, it's not the end of the world. Okay, we can talk about this again in our next lesson. If you want, Karaba, I can explain this to you because I just wanted to give everybody an opportunity to see whether they could do this on their own, okay? I don't know whether you guys will be able to do both in the amount of time that is finished, Okay, but there's number 1 and there's number 2. Let's see how it goes. All right, again, like the example, all right, what is missing, all right, is the value of r. Okay, I want you to do the theorem of Pythagoras to calculate r, and then I want you to answer the question. So in number 1, I want you to answer the question cos theta, and I don't think there's going to be time for it, but if you are feeling snappy, then maybe you could manage to do question 2. Okay, Karabo, so everybody else carry on with that. Karabo, can you tell me either via the chat or unmute your mic, what is it that you didn't understand? Karabo, I don't know if you can hear me. Finding the R part. Okay, so was it the theorem of Pythagoras? Okay, so let's just move that over because then, okay, no problem, Karabo. Let's do a question here together on the side, all right? And that'll give people a chance to get those finished. Okay, so there is a set of X and Y axes, right? So let's pretend that the terminal arm, which is attached at the origin, let's draw it in a different color, has now swung in an anti-clockwise direction, and it's come to rest over here. There's the end, okay? And the coordinates at the end here are going to be -7 and 24, okay? What I'm saying is that in terms of this diagram, the X coordinate is equal to -7. The Y coordinate is equal to 24. We want the length of OP. OP is the hypotenuse or the radius. Okay, so because this is a right-angled triangle, if we drop that line over here, we've got a right-angled triangle. Okay, this side over here is Y. This side over here is the X. And this side over here, opposite the right angle, the one in black, now I'm drawing blue over it, that is R, the length of the hypotenuse. Okay, so we are going to use the theorem of Pythagoras to calculate what R is. So in other words, the theorem of Pythagoras tells us that X squared plus Y squared equals R squared. That's super, super important. Now what we do, now what we're going to do, Karabo, is we're going to sub in. Okay, so we're going to sub in what our X is, which is -7. So we write brackets when we substitute. We put the -7 inside and we square it. We put the 24 inside and we square it. Right now on your calculator, cool Phoebe, you've done both of them. Okay, Maruma, well done. All right, that's lovely. I'm just going to finish this off. Okay, if you then put this exactly as you see it over here, Karabo, into your calculator. So bracket -7, bracket squared, plus bracket 24, bracket squared, and you press equals, your calculator is going to tell you that R is equal to, what's your calculator telling you? It should be saying 625. And now you're going to take the square root on both sides. And then you should get an answer for R as 25. Okay, so we're just working with the theorem of Pythagoras. Karabo, I hope that helps. Everybody else, there's a few of you that have managed to do all of this. Well done, guys. That's really nice. I've got my grade 7 lesson after this. So I'm just going to finish just 2 minutes earlier. But let's go back here and go and see what answers we got, and we can talk about it, and then we can say goodbye to one another. Is it a little bit better, Karabo? Okay, you just have to keep trying. Okay. All right. So in question number 1, who was the first person to say that they were finished? Harry again. Okay, Harry, what did you get as the value of cos theta, Harry?
I got 3/5, ma'am.
Oh, Harry, that's wonderful. So did I. There we go. There's my answer. Okay, so did you guys get the same thing? All right, so you worked out the length of R, you got 5, and then cos theta ended up being 3/5. Good job, Harry. Well done. That's lovely. Okay, Sam, you got the same answer. So thumbs up from all the people that got the same answer as Harry. Cool, Phoebe. Cool, Nizola. Well done. Good, Maya. Good, Jared. Well done, Anam. Okay, so now let's have a look at the one on the right. Hopefully you guys have had a chance to be able to do this too. I'm going to call on Marumo. Oh, Nizola, you got -4/5. Cool. Marumo, what did you get? Thanks, Nizola.
Ma'am, R, I got 10.
R, you got 10. That's right. Perfect. Good job. I also got 10 for R. Okay, so OP or R. Well done. And then what did you do? How did you write sine theta? So this was the question. Okay, you got -6/10. Yes, you're both correct. Okay, so again, this is one of those that we would have been able to simplify. Okay. Oh, sorry, not -6. It was supposed to have been -8. Okay. So here, yes, Harry, quite right. Okay. Mohamalepe, just remember, when we're working with sine theta, we're working with y/r. Okay, so the y coordinate is this one over here. Okay, and that's why we would have written -8/10, which is -4/5. Okay. Good, well done. Well done. Okay, grade 10s. Unfortunately, I'm going to have to move over to my next lesson. I'm going to leave you in the hands of Tula. I hope this evening's lesson made sense. Perhaps you can give some feedback to Tula and then he can let me know. But we're going to carry on with this in our next lesson as well. I'm going to show you some more things that you need to know. Anyway, I hope you enjoyed this evening's lesson, and I'll see you guys all again on Thursday. Okay, bye everyone.
Hi, Lee. Thank you very much.
Thank you.
Hi, grade 10s. I don't know if you guys can believe it, but we are almost at the very end of our trigonometry series. Let me just show you. I just want to, before I continue, just give me an indication on the chat of, just from a scale of 0 to 10, how much you think you have a grip on trigonometry. Please just let us know, if including those who are watching on the live stream, just let us know how you feel about trigonometry, just so we get a sense of how everyone's doing, and then we'll take all that into consideration, maybe going into revision and things like that. So Like I was saying, we are almost at the end of this very series, and we have come a long way. I know a lot of you, I'm seeing a lot of familiar names. So a lot of you guys have been with us since the very beginning, and we are on our 5th lesson now, going to the 6th lesson. And after this, we'll be moving on to analytical geometry. So from next week, Tuesday, we'll be starting with analytical geometry. I'll give you guys the course schedule for analytical geometry on Thursday. Yeah, when you guys join us on Thursday. So just watch out for that. And remember, at this point, it's very important to stay consistent. This is the most important time. You guys are going to be moving on to your exams, and the year is almost finished. So just stay consistent and make sure that you attend every lesson. If you happen to not be available for the lesson, you can always go to watobi.co.za to catch up on the lessons that you missed, or there's something you didn't understand, or the teacher moved on too fast from a slide. Always take the time to go back and catch up, so you make sure that you are consistent in understanding. And of course, we like to always give you guys homework. So go to your Watobi app lesson, click on trigonometry as this shows. When you click there, scroll down to trig on Cartesian plane, and then click on trigonometry on the Cartesian plane. And then on there, watch the lessons that are available there. Do the activities that are available. You can take a screenshot of this or write it down. And yeah, make sure that you do this so that you are, and if you do forget maybe on what the homework was, again, go to watobi.co.za and make sure that you write it down, and you take it from there. You can always catch up on that. So yeah, I think that's it from me, you guys. Does anyone have any question just on the progress of the lesson, or anything at all that you have on your mind that I can help you with? Shame, Katlego. I see you have 0. Let me see. Everyone else has slightly high numbers. Hopefully, I think there might be a revision on the trigonometry. I'm not promising anything, but I think there might be. So I think you guys will be able to catch up then. So yeah, for those with low numbers. But yeah, I'm glad to see that a lot of you are starting to get it. If there are no questions, I think that's where we'll leave it for today. I'll see you guys on Thursday. Don't forget to do the homework and come prepared. But for now, goodbye. Enjoy the rest of your evening. Bye.